Hi, my name is Andrew Townley, and I want to welcome you to What's Wrong with Threat Modeling and How to Fix It without going crazy or getting overwhelmed. If you don't know me, I'm Archistry's founder and chief executive. And what I do is I help the Global 500 build effective, value-driven security programs. I've written some books on the subject. I've written a book on AI, and I've been in this industry space for over 20 years and over 30 years of professional career in technology, focused on large-scale organizations, public sector, systems integration, service-oriented architecture, enterprise architecture, and security at all levels, really. So I have been there and done that from a threat modeling point of view and a risk assessment point of view and a security architecture point of view and a technical architecture point of view for a really long time. So let's go and give a very, very brief intro to threat modeling and what it is. If we look at what the goals of threat modeling are, I like Adam Shostak's three goals of why we threat model. First is to find security issues early. The second is to better understand what our security requirements are. And third is to deliver better products. And these three things are great from a software delivery point of view, but they're not the whole story. So I often see people struggle or have conversations about what the difference is between threat modeling versus risk assessments. And really, it comes down to where you sit. And I mean that quite literally, because if you look at it from a development perspective, here is what I kind of use as my reference model for the recommended DevSecOps activities. Developers call it threat modeling. And if you look at it from a risk management or an enterprise risk perspective, risk professionals call it a risk assessment. But if you really look at what those objectives are, it's really all the same thing. So let's talk about how we generally approach threat modeling. And when we talk about threat modeling, it's normally, again, from the delivery perspective, and we start from the application. So in this case, hypothetically, let's talk about a banking application. So we think the application, we look at it, and we break it up into what its components are. So maybe there's a mobile app, some services, the third parties that are helping in providing services for the bank, the clearing houses, the other bank exchanges, and all of the moving parts that are part of the business of banking. And then we break those down into some services, maybe loans, personal banking, payments, maybe business banking. And then those services are broken down into features like edit personal details and make payments. And then finally, once we get to that point, is where we normally start threat modeling. So we identify a bunch of features, and then we can walk through the process of doing a threat model for the features. Now, I didn't want to show you my way of doing this just yet. I wanted to compare this to what people understand in the industry. And one of the good examples that I've found is Jim Grumbly's a walkthrough of a threat model that he did on the Martin Fowler website from ThoughtWorks. And Jim, I don't know personally. He's a consultant at ThoughtWorks and has been around a long time and definitely knows his stuff and knows what he's doing. So I'm borrowing some images and the flow from his article, which is the link there at the bottom. So if you want to find out more, you can go and look at this link. But we start with a feature, so edit customer details. And then we do some modeling. So we identify the key elements of the feature. Here we've got some boxes and a customer. And then we look at the data flow. So we identify the data movement between the different boxes. Then we identify what the nature of that data is and how sensitive it might be. So we're identifying the data assets. Here you can see there's PII and there's credentials involved. And then ThoughtWorks put together some really cool Stride reference cards that I referenced in some of the other things that I've done in the past. But I found them from his article actually a long time ago. So you go through the Stride methodology and you brainstorm threats and abuse cases, and then you come up with your annotated, prioritized list of potential threats that are relevant to that feature, and you prioritize the threats by risk and you put them in the backlog, and then you figure out how you're going to deliver it. So this is a very, very quick walkthrough of the process and the detail. There's quite a lot of detail in the article that Jim wrote and goes through. But at the end of it, it's a lot of work to go through, and then phew, you're done. But wait, because that was just one more of the total number of features. So I built this banking reference model for some of the other things that I do to teach from and talk about. So I'm not using any customer information directly, or this is, coincidentally related to some of the banking clients that I have, because banking is kind of all the same. It's divided up in different ways and different groups, but fundamentally it's all the same stuff. So this is a hypothetical reference model of a retail banking system, and it's the conceptual architecture. So you can see here from the conceptual architecture, we've got the credit team and the fraud team and the audit team, customer service. We've got a bunch of services inside there. So, the account listings and the loan services, payments and customer services and budgeting and whatever. And then you've got the retail customer sitting on the outside, and then there's partner service providers to do the loan validation, and then there's the external institutions that facilitate the money transfers and all of these things. So we could look at this and we could say, well, there's a number of different features and components just from this high-level conceptual architecture of what this banking system is supposed to do. So I've identified 10 here. And there's the banking app, and the mobile phone you may not think is actually important, but it is, because that's where the mobile banking app runs, and there's some security things that you would want to consider from the perspective of the mobile phone, even though it's not actually part of our side of the solution if we were providing this as the bank. Then there's the internet connection. You edit personal information, make some transactions, request a loan, view and edit those loan requests, go back and forth, provide more details, evaluate the offers, and go back and forth. Then there's bill payments, and if you pay the bills, then you got to manage those payees. And then the budgeting categorization of your different budgeting stuff we can talk about as a feature as well. And if we even just take this 10-item list of features and components, that's not even all of what it's actually supposed to do. If you look at it, there's potentially quite a lot of other things that the banking application could do. And then once we get it to the feature stage, then we do the user stories and we go through and we look at it, and then we do our threat modeling. So, threat modeling comes normally in the design phase of the DevSecOps delivery lifecycle process as you go and you start looping. But then we need to kind of zoom out, because the problem we see in threat modeling is that it's a development focused activity, and everybody looks at the DevSecOps loop, but they don't actually look at the end-to-end delivery process. So what I've done is I've taken the standard delivery pieces, and there's 14 different steps in any sort of delivery from inception to actual service deployment. And I've kind of arranged them in an alternative view of the DevSecOps, or just DevOps, or Agile delivery, or even non-Agile delivery, but most things are Agile these days. And if we look at the whole delivery cycle time across multiple teams, we can look at what the program or service lifecycle is. And it starts off with an idea, and then there's the customer journey mapping, and then there's this conceptual solution. Now, you could say that the conceptual solution is what we did, but that's generally a little bit more detailed. That comes in a little later at the point of view where you are talking about deciding how you're going to deliver this. And so generally I use a term from Amplio called value increments, and then we go through and break that up and decide what that minimum viable chunk of valuable functionality is going to be. And then we do a conceptual architecture and increment feature set, and then the solution architecture based on those features. And then once we do that, then we go into delivery, and we go through our different sprints, and then we do our daily activities here. And if you look at any kind of large epic kind of relation, which is another common term for value increment, they're a little bit different. I prefer value increment for a variety of reasons, but for now we can talk about them the same way. We're talking about, on average, for multiple teams, about 20 weeks of delivery for any kind of major epic. And then that's broken up into generally 2 sprints of 10 weeks. Each sprint is then 2 weeks, and then you've got the daily activities amongst those different sprints. So if we then kind of really zoom out and put this in perspective, we can look at the figure on the left. Now, the figure on the left is like delivering 2 iterations of a value increment over a number of time periods. And so we've got the, inner group of a couple of sprints doing our feature delivery. And then we've got another couple of iterations of that, which are value increments, and then we've got our epic delivered. And then we do multiple value increments for conceptual design. But so this is like, a year's worth of delivery in 2-week sprints, typical agile kind of thing. But what people don't really think about is where DevSecOps fits in here. Because DevSecOps is really just around the sprints normally. And you've got your sprint stories, you do the detailed design of those, and you go into the cloud configuration, coding, testing, all of the continual delivery stuff. And then when we talk about it and we think about it, we think that DevSecOps is the whole thing, but it isn't. Because any large team, especially like the global 500 customers that I have, there is the delivery side, which is the agile delivery part, and then they are delivering things that were fed to them based on, the business and the marketing and the enterprise architecture team, and then, all of that stuff is upstream from the actual cycles of the DevOps delivery. Now, this has some interesting implications for what I call normal threat modeling. So let's just go ahead and make it simple. I like to come at it from the point of view of operational risk. And if you do that, there's really only 3 fundamental risks that matter. One is that whatever it is you want isn't available. So at whatever level that means, you have a system, a service, a piece of information, an app, a product, or whatever, and you want it and you can't get it. So that's really the first operational risk. The second one is that it's not fit for purpose, or it just doesn't work right. Kind of the same thing, doesn't meet its requirements. And then the third one is that it's just not used, or the value is not realized for some reason because you don't use it correctly, or you can't use it, or whatever. And I like these because it makes sure that you avoid the threat explosion. I mean, I used to use a bunch of different threat taxonomies, and I was big on several of them, but we don't need them. If we really pull it back and we look at what matters from, getting the thing we want, everything really rolls up into these 3 core events, and then we can decompose them as we need. So we're going to expand this into a more complete risk taxonomy so that it's a little bit more aligned with what people expect from a threat modeling point of view, a little bit more aligned with Stride, and we can talk about some little bit more level of detail that is going to be useful to us. So we're still going to start with the thing is not available, whatever that thing is, because this one's pretty basic. The thing doesn't work or meet expectations. Again, this is also fairly straightforward. Now, the other thing that I normally roll into that is that whatever it is, once we get it and we try and use it, it actually has unintended consequences. Now, what this allows us to do is deal with things like, malware or, any kind of thing that the user didn't expect they were going to get whenever they got whatever it is that they got. And those consequences may have direct implications for them, or often it's indirect, or they may not notice it for some time. The next thing is breaking up that third one where the value is not realized or it's not used. So it isn't used as intended is one class of the 2 types of fundamental errors that people make. One is errors of omission, so people don't do something they're supposed to do, and that's what we've got here in number 4. The thing wasn't used as it was intended. And then we've got the other kind, which is the error of commission, which is the thing is used other than as intended. So whether this is maliciously or accidentally or because they're having a bad day or whatever it is, it doesn't really matter. And that's another thing that I like about taking this kind of approach, because it really, the whole insider threat thing doesn't matter anymore, because it's not about motivation, it's about what can happen. Because if you're prepared for what can happen, it doesn't matter if it's your star employee on a bad day or if it's somebody who's really trying to commit fraud or do something really nefarious, because you already anticipated what's going to happen. The next thing is that the thing is somehow replaced by a malicious actor. Now, this gets us into the spoofing territory of Stride. So whether it's, providing an alternative website, whether it's being able to try and, harvest credentials that way, whatever it is, phishing emails, doesn't matter. This is really in the bucket of spoofing, and that's what number 6 is about. Number 7 then is the thing is modified after validation or provisioning. So this is tampering, obviously. And so what I mean here is that you get it, you validate it, and then you put it on the shelf. And then so somehow or other it gets messed with, whether it's after you've validated it or before you get to validate it, and somehow, makes you assume that it is actually not tampered with, which kind of crosses the border a bit between spoofing, depending on how you look at this. But we need to cover this scenario because it's a valid thing that occurs. So number 8 is that the feature or function, the use of that feature or function is actually denied by the user. So I didn't make that transaction. I didn't, look at that information, whatever it is. And again, this is really a error of commission, but since we're kind of talking about threat modeling and we're talking about Stride, it makes sense to kind of pull it out here to make sure that it's clear that this is covered in what we're talking about. The 9th one then is the information is disclosed to unintended parties. So this is obviously the disclosure. And then the last one is that the thing is accessed or operated by somebody other than and as intended. So this is somebody privilege escalation. They don't have an account. They've taken over somebody's account, whatever it is. However they manage to do that, the net result is that you are thinking the service is being used as the service provider by somebody who actually is not who you expect. And this is, again, something you've got to be prepared for. So then if we go back and we look at our feature and components list, what we've got in terms of our delivery cycle is we've got 13 core features. We've got 20 weeks per feature, let's say. And the mobile phone and banking app I'm throwing in as features and elements here, just from a planning perspective. 10 sprints each. And then we can do some basic math here. And we've got 13 core elements. We've got 10 risk factors, which gives us 130 potential risks or threats. Now, if you were to go through and you were to do Stride or traditional threat modeling, I mean, this is kind of the list you would end up with if you covered all the bases, which means it's really 10 times around those same 10 threat trees. And you have a product to ship, and it's not really going to get done. And we wonder why security becomes an optional extra when the scope of work to threat model it ends up to be like 130 things for a given feature. So let's fix it, because the reality is threat modeling is not doing the job we would like threat modeling to do. So if we're going to fix that, we need to kind of take a fresh look and see what we can do. So let's start over at the top. We've got our features and components. We've got our banking. We've got our model of the way they interact. But rather than kind of going through that process and going down the levels, let's look at what's really important here. And what is really important is value. But where does value come from? Well, got to take a little bit of a side trip to basic economics first to make sure that we're on the same page about value. Because a lot of people get this kind of wrong, and it's important to get it right if we're going to get the leverage that we can get from our threat model. So basics of economics, we have a customer, someone with a need or a job to be done. We've got some supplier with a value proposition to meet that need or help do that job. And they connect and get together. And once they do, goods or services are exchanged from the supplier to the customer. The customer uses them in the ideal situation. The supplier is compensated for delivering that good or service to the customer. So the definition we can use about value, and this is where people tend to get it wrong, is that value is actually someone's subjective assessment of the satisfaction they're going to get from something that they believe will meet one or more of their needs. And the key thing here is that it's subjective and cost is not value. Because if cost and value were equal, why would you exchange anything? There would be no point. That's not how it works. It works because everybody thinks they're getting something more than what they give up out of the economic exchange. Otherwise, there would be no economic exchange. And so we need to look at the thing that's being exchanged, which is an economic good. And that's something useful that's capable of satisfying a need and whose availability is less than the total demand for it, meaning it has scarcity. Because again, if it's laying around and like sand on the beach or, air in the atmosphere, it's not really scarce, so you can get it anytime. Now, if we take these things and we look at our Banking Act again, we need to identify, well, what are the potential goods or services in the banking app that's going to do something that's going to be of value to people who you want to use it? I mean, the customers are doing business with the bank for a reason. So what is that? Well, the banking app is really their channel to their money. So that is a potential good and service. The mobile phone that they're using is the value that it provides is access to their money. Internet connection, again, is access. View, edit personal information. Okay, well, there it's a sort of PII type of deal. And if we make our transactions, then the value there is really the transaction. So it's either that they can prove that they made a payment or they can prove that they got money and they have money to spend. Request loans, again, the same thing. It's the transaction. The value is the good or service that's involved here is really the transaction itself. Same with view and edit loans, same with bill payment. And then manage PAYE or manage the payees is really, again, the PII for potentially the people who are the payees. The nature of the services, it depends on what kind of, things people could surmise based on, who you pay and how often and those sorts of things. So it can fall under PII depending on how you do it. Now, if we then look at our budgeting, it's the same thing. It's transactions. Again, you could argue potentially PII there based on the categories, but I'm going to just say the value is in the transaction. So now, instead of 10 things, we've got a smaller number, and it gives us a little bit of leverage. It's not bad, but we can actually do better. So how are we going to do better? Well, let's reclassify our application parts. So we've got kind of things. So we've got the banking app, the mobile phone, the internet connection. Then we got all the features and functionality. So we'll put that in kind of one pile. And then we got the goods and the services. So the money, the PII, the transactions, and the access. Okay, so again, we're kind of playing around and we're trying to organize things a little bit, but we're still not quite there. We're getting there, but we're not quite there yet. So one of the things that I've developed over the years of doing this stuff, and even before I did security architecture, I kind of did this from just solution architecture and enterprise architecture perspective, is to kind of have a set of boxes that I always use. And it turns out that pretty much every organization on the planet, you can use the same set of boxes. And I call those boxes the baseline perspectives in the Agile Security System. So when I published the Agile Security System first in 2019, I built this set of models that were based on everything that I'd done with clients. I used to draw custom models for each client, And then I realized that that was kind of stupid. So I said, well, it would be a lot smarter to make one model and start from there because basically they're all the same anyway. So what are these boxes really? Well, these boxes represent essential collections of things that are meaningful to the organization that we might want to talk about. And the good thing about this model is that if we get the right boxes, this is a unification point of everybody in the organization because everybody talks about products, everybody talks about information or data, everybody talks about systems and platforms and customers and value and stuff like that. So it gives us a point of intersection between the different functions of the organization, business and technology, technology and security, security and the business, business with each other. And we can anchor what it is we're talking about in the same concepts. So then we can take those collections once we've got that starting point and then divide them as we need to organize anything that the organization cares about because it's got to fit in one of those boxes somehow. And if it's not in one of these exact boxes, it's still in either the blue box of the inside or the kind of gray box of the outside. And the public internet box is really the connection that the organization allows to the world. But it's still kind of on the outside, but it's kind of a window to the outside. But then the thing is that each one of these boxes participates in one or more kind of fixed relationships with other collections. So we know based on what these things are, the way they work together to deliver value for the organization in a value delivery network. So this gives us a really powerful fundamental model. And once we kind of got this model and validated it, like I've done over decades at this point, then now we're actually working with what we can legitimately say is leverage. Because if I have a common way to organize whatever it is that I find, then I can start to trust that and I can use it and use that as the focal point rather than all the little bits and pieces that we've picked up so far. So how would we actually do that in our reclassification and apply the baseline perspectives into helping us with our threat modeling problem? Well, first thing we do is we take our banking app and we bundle it in with all the other things that are kind of, like I grew up watching Sesame Street and they used to have this part of the show where they would divide the screen into four areas and there were these four little kids and one of them was doing something completely different than the other ones and they would, do this song. One of these things is not like the other. And really, Sesame Street is architecture training because that is one of the most important things you can do is organize things and find the ways that make the most sense to organize and that gives you leverage so that you can work with things as powerfully as possible without getting lost in the details, because that's what architecture is all about. So we put the banking app in with the functionality, and then we can draw a box around that and say, well, this is our applications. Then we can say our mobile phone is a platform, and we're going to say our internet connection is the public internet box for the sake of it for now. And then we're going to move our access good and service into the public internet box because that's what it provides. And then we've got the rest of it left over, which is all on its own, which is the information that represents the money, the person, and all the transactions. So now we've got four things that collect everything else, but we're still not quite done because we've only put them in the boxes. We haven't actually leveraged these classifications to help us do anything more than we would otherwise do doing a traditional approach to threat modeling. So first thing we know is one of these core relationships, and there's a bunch of scary lines on the baseline perspectives that represent all of these fundamental starting point relationships. But we know that platforms host applications. So that gives us a fixed thing to think about when we're talking about the interaction between platforms and applications. We also know that platforms host information in the form of data. So I skipped over the sort of distinction between information and data. Information is something that represents the concepts, and the data is the actual tangible, structured representations of those, whether it's on a piece of paper in a form or in just sentences, or if it's, in a database or on a hard disk somewhere or whatever. But the point is that platforms host information, they host applications, and applications then transform information or data into more data that then represents information. So again, there is an information domain and a data domain that I didn't include on this diagram for simplicity, but there is a relationship there. But if we look at it, then the applications transform information, and then the internet connects the platforms, and it allows the information to be transferred. So this looks really, really simple, and that's kind of the point. But if you really understand what it's telling you that risk happens on the lines, not in the boxes, because if there's no lines, everything's in the box and nothing can interact. Those lines represent the interactions between the elements in the boxes, and the interactions are where the risk comes from. Because if you put it in a concrete bunker and bury it in the ground, it's 100% secure, but it's definitely not useful. So we need to, again, find the leverage that allows us to manage the complexity of the worlds and the technology environment that we're dealing with here. And now we can really start to see what we're truly working with here. So now that we've got everything in boxes, we got 4 core domains. We got our 10 risk factors. We haven't changed those, but that means we've only got 40 potential risks or threats that we've got to deal with. Because in fact, if you look at the threat models, view edit information for transactions, view edit information for one kind of transaction versus another kind of transaction, the stuff that varies is maybe the nature of the information. But based on that information, you got to worry about the same things because it's just those 10 risk factors. You may mitigate them in different ways. You may have different mitigation requirements based on the kinds of information that it is, or the service, or the user, or these things. And this is why we can subdivide those boxes, because we can specialize those boxes, but we still don't want to lose the power that we get from this encapsulation of all of the detail into things that are meaningful and useful for us. But it gets better, because what are we really talking about now versus what we had before? Well, before we had 13 core elements, 10 risk factors, so we had 130 potential risks or threats. Now, what we've got now is 40. So we've taken 130 down to 40 from an assessment point of view to figure out what is really important. So we've reduced the complexity and effort tremendously in terms of what we've got to do, because we've recognized the commonality between all of those things. And there's quite a bit of it, but we can't find that commonality if we just look at the features and components from the initial list, because it doesn't look like they're the same until we actually look at it and think about what they're doing and how they work and how they're going to be implemented and where they're going to live and where they're going to sit. So that's why we can take the things from the model and put it in the boxes, and then think about the way those boxes interact and get our leverage. But that's not the only thing we did. So we also reduced the frequency and the pressure involved in doing this. Because again, in the traditional DevSecOps model, if you're talking about a sprint going through and every 2 weeks, then theoretically, you're supposed to do threat modeling every 2 weeks. And that's one of the reasons why it doesn't get done, because there's delays, there's problems, there's, all things that come up. I mean, I've written code, I still write code, and did some fairly major software projects on a global scale. And there's always something that comes up, as you well know, if you've been around a while. But we're doing this every 2 weeks, and we're being asked to do it every 2 weeks, and that's kind of why it's not happening. But if we look at what it is that we're actually dealing with, then we can look at our risk assessments, and we can actually do the risk assessment at the conceptual model. The very first time somebody on the back of a napkin or a piece of paper or a whiteboard draws boxes and lines and says, these are the things that are going to work together and interact and communicate, and this is the information that they're going to do. It's a loan, it's a, personal details, it's whatever. That's all you need to actually understand what the real risk exposure is to the business. And that means that we can do a risk assessment every time there is a design, but it doesn't change unless the design changes. Because what we really care about is what is the potential risk impact to the organization if something goes wrong. And the something that goes wrong is one of those relationships between the boxes doesn't work out the way that it's supposed to. And we've got those 10 factors that we can look at that. So we can then do it early, and based on what we find out, we can figure out, okay, well, we're likely to use this cloud platform, and that means because this is PII, it's got to be protected in this way. That's going to mean that we need XYZ controls, and on that platform, these controls are configured this way. We can bundle them up into a standard. We can give a blueprint for how it's going to work. We can package them into a component that is custom, and you just link it into the code. And we can do all of this in the time that it takes to get to the part where DevSecOps starts for something from when we get a design. Now, this is a continual cycle, I get, but there is a start of new stuff. And so if there is a start of new stuff, then you can do this at some point in time and then start to get the benefits of it. But that's not the best part. The best part is that it actually works across applications too, because the next project comes along and it looks totally different, but yet everything in that picture on the left has to go somewhere in the boxes on the right. And if they're the same boxes in the same environment, then we already know what the requirements are. We already know what the specifications are. We've already got the components figured out. We've done all of that work at the low-level details based on the analysis. But again, we're doing it once. We're not doing it every 2 weeks. We're not doing it randomly. We're not under pressure to do it because we've got code to ship. We are actually doing it when it needs to be done, as soon as it can be done. And then we have lead time to make sure that all of the controls that are going to be necessary are necessary, and that we can integrate them in an easy to consume and measure and assure and monitor way into the CI/CD pipeline, so that we don't need gates, we don't need all this verification, because if the pipeline works, then we are secure for the mitigations that we have. And every new thing that uses those same boxes, if they're smaller, you got the Azure box and you got the AWS box or the Google box or whatever, but you figured it out once. And everything in that box is subject to the same risks, the same risk exposure, the same technical threats, and you do it one time. And when I tell people this the first time, they don't really believe me. And so I want to walk through why this is actually possible. To do that, we need to kind of look at where risk comes from. Now, I have leveraged the SAMHSA methodology for a very long time, and I like the 6 layers. I generally only worry about the first 5 because the 6th one is the overlay and it kind of is everywhere. But let's look at it from the 6 layers. So we got the contextual, conceptual, logical, physical component, and operational architecture. So contextual is your business context. The conceptual is our conceptual model. We have a banking app. We've got these different, as soon as we can describe it, that is a conceptual architecture of the solution. We can break it apart into more detail, but when we talk about it in terms of concepts, that's what our conceptual architecture is. Then we've got a logical architecture. This is when we get into the implementation. So this is our solution design. We've got the physical architecture, which is kind of our nature, the shapes of the components. So we will have a server. We will use virtualization. We will, do whatever these features are. These are the features and mechanisms of the things, the classes of solution components that we're going to use. That's kind of our shopping list. And then we go find the vendors, and then they give us the components, which have part numbers and invoices and all that stuff. But there's traceability through the whole thing if you're not familiar with the SAMHSA model. And then the operational architecture is how you go through that entire life cycle and then operate it as once it's there. But the top two blue layers are the business decisions about what to do, what's important, and where to do it. And if you really look at it, those are the things that define what the risks are. We are going to be a bank. We are going to offer loans. We are going to offer crypto. We are going to not offer crypto or loans or to particular type of customers. We're going to, serve a particular market segment. All those are actually the decisions that determine what the risk exposure of our banking application is really going to be, because those decisions are controlling what the possible implications and impacts can be when things go wrong. All of the green layers are implementation. So the implementation design choices are about technologies and the exact features and functionality, but those design choices don't change the fundamental risks. Now, this is where people push back because they're like, oh, well, the threat environment and vulnerabilities and whatever. That's not changing the risk from a business point of view. That is potentially changing the vulnerability and the viability of a particular component, but that's just the potential and exposure and mitigation options that we need to consider for that. But if we've decided we're going to use a particular tool or technology or platform, then we can still do that once, because everything that is going to run on that platform is going to have the same requirements if they are in the same box, which means they have the same shape, they're processing similar information, they're dealing with transactions, they are using this kind of database, they're whatever they are. But they don't change the business risks of the thing not working or the thing being breached or somebody, claiming that they didn't actually press a button. The technology has nothing to do with that. The technology is actually going to just make it easier or harder to prove that that risk has been managed. So the first thing we really have to do if we want to get our head around this is separate those two pieces, because the risk is not directly related to the technology, because the business will exist without the technology at some point. I mean, you saw people with paper boarding passes for the airlines that decided they were still going to be in business and fly versus the ones who said, oh, my system doesn't work. And they lost hundreds of millions of dollars of revenue that day. But not everybody did. So if the business can still work without some of the technology, or certainly some of the features or whatever, then this is actually what the risk exposure is that matters. And the technology stuff is just the means to delivering the business value that we're supposed to achieve. Then we get into the operational architecture stuff. And these are the day-to-day decisions, which really are where all of the errors of commission and omission come from, because those are the only two types of errors they are. People do things they're not supposed to do, or they don't do things that they should have done. And basically, if you look at every breach, this is what we're looking at. If you look at where all of the problems have come from, vulnerabilities, people did not do X, so that's an error of omission. They didn't do the, data validation. They didn't do error bounds checking. They didn't do something that they were supposed to do, and therefore there was an exploit. And oh, by the way, it cost this company millions of dollars. But that exploit is traced back to an error of omission or commission somewhere. Now, the thing is, you can't control those, but you got to accept that they are things that you can't control, and you got to be prepared for them. And again, this changes the nature of the way you think about risk and mitigation and security controls and all of it. But if we don't understand the nature of the risk that we're really trying to manage, we are not trying to manage the cyber risk or the technology risk in isolation. Because if we can make expendable containers or servers or whatever, because we can replace them before we need them, even if that's down to seconds, then that's okay because the business objective is still delivered. Now, it comes down to a cost and viability and management perspective, and those are design decisions for sure. But the point is not about whether the thing is secure or free from vulnerabilities or that. It's about, does the business objective actually still get delivered, even if the machine falls over, or even if somebody makes a mistake, or even if somebody is trying to commit fraud? And if you can't answer that question, then your threat models actually don't matter. So let's talk about what we really did in this walkthrough and why it works. Because this is one of the other fundamental things people don't understand about architecture and security architecture in particular. So let's walk this through from the perspective of looking at the process that enabled us to go from 130 things that we had to deal with down to 40. So we started with an application and we broke that down into smaller and smaller and smaller pieces. Now, this is the process of analysis. That's what we do. We take something, we take it apart, we look at what the parts are, and we decide if we can take those apart, and we get to some sort of end part that is small enough for us to manage. And this is, since the Renaissance, reductionism 101. You divide and conquer, take it apart until you've got a part that you can manage, and then you manage that part, and then you hope for the best. Because what you don't normally do is go back up. And that's what we did here. So we looked at the way that those parts were decomposed, the application into the major components, into the features, into the details of the things that those features were really doing. And that allowed us to apply the process of synthesis to go back up and change some things around. So what we did was we realized that we could reclassify things, not in terms of elements and features and application stuff and whatever, that we could reclassify things in terms of the public internet, value, information, applications, platforms. And we can leverage that in a different way because it doesn't matter how you look at the parts. You can organize them in an infinite number of ways. What matters is which ones are most useful for what you're trying to do. And different things, if I'm going to implement it, yeah, I need features for sure, because that is the bite-sized chunk that I'm going to deal with. And then I'm going to decompose that into user stories. And then I'm going to decompose that into code and procedures and lines and, bytecode and whatever else. And down it goes. But from an architecture point of view, that doesn't matter, because if I've got them classified the right way, I can treat them the same. So what we did was we went all the way down and then we came back up through synthesis, which is basically finding the holes. So what parts of that value are related? Well, we've got the features, okay, and those are part of the application, and then this is part of information, and then that allowed us to change the way we organized the things that we were dealing with, and that gave us power. That gave us the leverage. So then we didn't have to focus on the bottom. We could focus on the parts that are really different and unique and know that all of the smaller yellow ones are going to basically behave like the bigger yellow one will, because they're all yellow, whatever yellow means. They're all AWS, they're all Windows, they're all Linux, they're all whatever. Retail banking versus commercial banking, whatever, it doesn't matter. The point is that you've got these classifications, and those reclassifications give you more power than without them. And that's really what architecture is. Fundamentally, architecture is a classification exercise by looking at the things and then figuring out how best to manage them. And this really comes back to the whole distinction between architecture and engineering, because an architect isn't your most senior engineer. An architect has a totally different skill set, because what an engineer does is engineering is accomplished by applying the process of analysis to figure out the best way to implement a single part. So if we let our developers, we give them an application, they do a design, they take that design, they break it into features, then you go down, 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 down. That's normal because they're engineers. And there's a little bit more subtlety between the architecture and engineering, because it's really a two-level thing. You can be an architect at this level and an engineer at this level, and then you go down, and then the engineer becomes the architect at the next level down, and it just goes on forever. It's recursive and scale-free. And it's also expansive and scale-free. It's the same model. But we want to make this distinction because it's important, because engineering is focused on analysis, and that's taking things apart. But they're taking them apart for the purposes that they have, which is implementing that part. But architects are different, because architecture is accomplished by a process of analysis to figure out the parts you need to deliver a given system's purpose or function. And then once you've got those parts, you then apply the process of synthesis to design the way those parts should be grouped together and connected to each other to do whatever it is you want in the most effective and efficient way. Because that is your design. This is the process of design. And an architect does this over and over and over again until they get the one that has the best trade-off. And there's a big difference between engineering, which is implement this thing, take it apart into the discrete parts that are small enough for me to do with whatever tools that I have, and the architect that says, okay, well, I know you're going to decompose them this way, and after a certain point, that doesn't matter because they're not unique. So let's figure out what's really unique about them so that we can figure out what our design needs to be, because it's the way that those big connections work as a system. And that's what makes the yellow ones different from the blue ones in the last picture. So this is why security architects are not just senior engineers, and it's why security architects can't just be stuck in infrastructure land or in delivery, because the security architect is the one person with the skills to be able to understand the details of the security and risk side of things and the architecture side of things by applying these techniques and processes to have the conversations about risk at the level of the business that the business needs to have, but they don't have if they're stuck 8 levels deep in an org chart in infrastructure reviewing, vulnerability scans, because that doesn't really help. Now let's look at what this really means in the process of our delivery picture. So remember, we've got our recommended DevSecOps activities, and that's basically our sprints, cycles, and the bridge between the feature definition and the sprint cycles. Then we've got our program, product, and service delivery activities at the top, those 14 steps. So architecture happens up front. That's where all those key decisions are made. You pick this platform versus this one. This one's going to be more secure or less secure than your other choices. But by the time we get into DevSecOps, we're in engineering land. And so all of the things from, the technical design, that's the link there, all the decisions that matter have been made. And yet we do threat modeling at the back after all those decisions have been made, and that makes us entirely reactive. It makes us do the same work over and over again. It makes us think all of the times we go through that loop, we're dealing with something new and fresh because we've never seen it before, because it was never part of our sprint, or it was not part of the feature that we did. But in fact, in the big red box, it's not new at all, because it's been designed and stable for months while everybody's going and trying to implement things. And again, the technology stuff may change. That's why the layers are powerful, because the rate of change is the fastest at the bottom and the slowest at the top. The bank is still going to be a bank with or without a mobile app. It's going to be, whatever the next thing is, and it's still going to be a bank. Those risk exposures and those requirements aren't going to change. The way those requirements are implemented and realized will change. And yeah, we need to validate. And I'm not saying security doesn't need to be part of the delivery process, but the way that it's a part of the delivery process matters a whole lot. And if we're spending all of our time doing reactive threat modeling after all the decisions have been made, then we're like, what are we doing? Like, really, what are we doing? Because we don't need to. It doesn't need to be this hard. Security doesn't need to be this hard, or threat modeling doesn't need to be hard. And in fact, it can actually be pretty straightforward. And it's one of the reasons why I put together the Security Architecture Accelerator program. Now, Accelerator was a deliberate choice because it is about making your architecture team incredibly more effective in a short amount of time by just shifting slightly the way they see the work that they do, and by the way that architecture is seen in the organization for the security program. So it enables the leverage in the red box and moves everything around so that you get more security better, more consistently, and you do it at the right place, not over and over and over again. Every time it's different, and every team does it different based on what they decide to think of that day, or what their stride brainstorming session was, or what people were thinking of in the abuse case, or what was on the news that prioritized stuff in, top of mind. Well, this exploit, we got to think about that. That's not the point. The point is we need to think about it in terms of architecture, and that's what the Architecture Accelerator does. So in the full program, it tells you how to talk about cybersecurity from a business point of view that makes the C-suite executives and the board not only understand, but they're willing to take action because they see the connection between security and what that means to them. And that's one of the big problems that we can't solve and haven't been able to solve for decades. We've been talking about, the security business divide for decades. IT security, I mean, it's all because we don't have the right way to think about what architecture from a security point of view is. Then you're going to learn why we need a new definition of security that doesn't keep us locked in the basement, chasing threats and waiting for the bad guys to strike. Because that's in reactive land. That's putting us back behind where all those decisions have been made. And we don't have a chance of actually being proactive and being resilient and designing things for the real world if all we're doing is reinventing the wheel every time we go through the DevOps cycle. We need to understand what our security architecture is really for and why it's not helping you much today. Because if it's just a diagram of the controls, or if it's just a list of the controls, or if it's the frameworks that you've decided, and it's not enabling people to make better decisions every day, then you've got a wall ornament. You don't have a security architecture, because that's what the job of security architecture is. Talks about exactly when and how security should be involved with project delivery to ensure business ROI is realized. Now, this is the continuation of why this threat modeling conversation matters and why the risk assessment versus threat modeling distinction is kind of important, because I'm making the distinction now that threat modeling is what happens too late, and risk assessments are what's probably not happening enough, or at least not in the right way, because you should do risk assessments the way you're doing threat modeling, but at the right time. And that's part of the shift. So there's also a very defined way to make sure that you've got the right security components in place, ready for the delivery team when they need them. And we touched on that a little bit, but in the accelerator program, I talk about exactly what it is, that how that works and fits together. Because if you don't have that loop closed, then you may have your architecture part figured out, but your delivery still has delays, or you can't validate the controls are still operating in the production environment or wherever they happen to be. And then finally, it's how to apply SAMHSA in a practical, useful, lightweight, and scale-free way that you've probably never seen before. I gave you a glimpse as to part of it, and people have the wrong idea about what SAMHSA can be. Now, I know how SAMHSA is presented, and I know how it's taught. I taught SAMHSA for 5 years, the official foundation program. So I know the way it used to be done. I haven't presented it recently, and I haven't seen any of the new materials, so I know they've changed some things. But fundamentally, people focus on the parts of SAMHSA that aren't where the leverage is. And I came to SAMHSA from a very different background than most people because I came from a delivery background. I was an architect before. I wasn't a security person. I wasn't a network person. I wasn't a system administrator. Although by that point I had been, I managed my own systems. I had defined solution architectures at the network level. I had, done all of the different domain architect kinds of work at that point. But my approach to SAMHSA reflects business and delivery and risk perspective that a lot of people don't bring to it. And we focus on the parts that work. We focus on the parts that are most important. And all of it is still there. All of it still fits together, but some parts are more important than others because that's how systems work. There are essential parts for certain things, and there are non-essential parts for other things. And just the way we did with our classification exercise, if we're going one way for one job, it's one set of parts are more important. One way of looking at it is more important. If we're doing a different job, that might not be the right way. And so what I've done over the last decade or so, about 15 years now, is take, well, actually almost 20 years is how long I've been exposed to SAMHSA. Because I met John Sherwood at a conference in 2006, and then David Linus and Andy Clark the year after that at COSAC. So I've been working with it and applying it in a long time, and I've kind of figured out how to make it work and then distilled it down into the fundamentals that I showed you, the domains, the interactions, the core relationships. And that's really where the power comes from, because I couldn't have told you any of the stuff I told you about threat modeling if it wasn't based on the foundation of SAMHSA that I use. So with that, I would encourage you to check out the accelerator program, and I would definitely encourage you to have a long thought conversation about the way you're threat modeling and start tracking it. Don't take my word for it. Track it. How many times are you actually getting consistent results? How many times are you actually doing unique things? How much value is that really giving you that you are getting on the basis of every time it's done? How often is it done? Is it done enough? All those things are things you can track. You don't need to take my word for it. You can prove it to yourself. And if you do the effort to track a few things, to lift it up and look at it and see how it's really working, not just whether it's done, I think you're going to find that everything I've said will be proven to you with your own data and with your own experience. With that, I'm Andrew Townley, and I hope to see you soon as part of the Accelerator program.